Another trend on the periodic table is called ionization energy, and it is the amount of energy that's going to be required to remove an electron from an atom. So the name really fits with what it does. So energy, of course, talks about the amount of energy required to remove an electron from an atom, and removing an electron from an atom is going to cause it to form an ion. So ionization energy. How much energy does it take to make it become an ion? As we move from left to right on the periodic table, the ionization energy is going to increase, which means it's going to take more and more energy as you move to the right-hand side of the periodic table to try to remove an electron from an atom. As you go from the top to the bottom of the periodic table, it's going to decrease, which means it's going to take less energy to remove an electron from an atom. So an element on the bottom of the periodic table is going to require less energy to remove an electron than an element on the top of the periodic table. So why would ionization energy increase as you go across a period? Well, if you remember, the electrons are going to be held more closely to the nucleus because we have smaller atoms as you move to the right-hand side of the periodic table. So those electrons are held nice and close to the protons, which is where they like to be. And so it's going to be difficult to take them away. So because it's more difficult, it's going to require more energy. So more energy is going to be required to take an electron away from an element like chlorine than it would for an element like sodium. They're both in the same period. However, chlorine is towards the right and sodium is towards the left. So it's increases in energy as you go from left to right. Now when you go down the periodic table, the ionization energy is going to decrease, which means it's going to be easier. So why is this? Well, remember that as you go down, the size of the atom increases, so those electrons are not as close to the nucleus, and there's not much attraction between the nucleus and those outer electrons. So therefore, you can easily take that electron away because it's not being held to that nucleus that much. So then, because it's easier to take away, then it takes less energy. So those are the two trends for ionization energy.